Hello, peoples. This video is definitely intended for the early on part of our dynamics topic when you're just learning to do some problem solving strategy with FBDs and forces and accelerations. FBDs are the most important part of each problem, and they are used as a visual equation. If you do it right, if your FBD is drawn correctly, then you let the FBD create the equations, and from there you do math. So this is a basic problem where you've got an object being pushed with a variety of forces. Actually, one of them you don't know, an unknown force, and these forces are at angles. There's friction, and that friction force is provided as just 20 newtons. And we also know that it starts from rest and it changes its speed over a distance. So that's going to bring us back to kinematics. All right, this is like a solid test problem. It's more than the basic problem, so let's get after it. All right, first thing I'm going to do is I'm going to draw a free body diagram of this piano. And this is a skill that you will get so much better with time and practice. Some people have a little difficulty with it, but after a while, you're totally good. So we have a force of 400 newtons at an angle of 25 degrees. It doesn't say anything about above or below, so we assume above. So this is 400 newtons at an angle of 25 degrees. Someone else is pushing left at an angle of 30 degrees below horizontal. We don't know what this force is. I'm just going to call it an applied force, F sub A for applied. Some people put F question mark. That's interesting. Other people put other things which won't be mentioned here. There's also a frictional force. It says that the object starts from rest and it's pushed to the right. We can assume that it's going to the right. Otherwise, I would have given it a negative velocity, which means that our friction force is to the left, not drawn to scale with the 400 newtons. I'm drawing this as 20 newtons. Technically, these arrows should be drawn to scale, but for this video, I'm not being too technical. What else we got? Well, we've got the force of gravity. Don't want to forget about that. We are on the surface of our planet. And even when you leave the surface of our planet, there is some gravity, for sure. Yeah, there's gravity in outer space. There's gravity where the space station is. I don't want to get started on that. But Fg, may I strongly suggest writing, equals mg, mass times 9.8 meters per second squared. And finally, this piano is probably on a surface. I hope so. Otherwise, it's fallen through the ground. Or somebody, I don't know, magically made it fly. So there is a normal force holding this thing up. This is the force of the surface pushing up. There is my free body diagram. Okay, that is really step one. After this, there are 3 other steps. Not always, but in general, there can be as many as 4 steps. Step 1, the FBD. Step 2, may I suggest, starting with the summation of the forces in the x-axis. I'm starting here because I'm new at this. And I just want to follow a procedure that will definitely get me to the answer. As you become more seasoned, you may realize, like, you know what, I'm going to start with kinematics. And if you already know that, good for you, because that's a good place to start. But if you don't know, go with the process. So we sum the forces that are acting in the x-axis that cause the mass to accelerate in the x-axis, or the horizontal. I don't think much about this. I look at the free body diagram, what points right, what points left. And I'm not talking directly to the right, just something to the right. In this case, we have 400 newtons acting at an angle of 25 degrees. By now, you know for x, we tend to use cosine. Minus 20 newtons to the left, minus an applied force, which we don't know. That's okay. Cosine 30 degrees. Those are all the forces pointing right or left. Those will cause the mass, which is 225 kilograms. I don't know how to write 225 apparently. 225 kilograms to accelerate horizontally along the floor. I don't know the acceleration. I don't know the applied force. Okay, no big deal. Let's keep going. I'm going to sum the forces in the y-axis. So summing, I'm going to leave a little space here because I'm going to come back to that. I'm going to sum the forces in the y-axis. The question is this piano accelerating vertically? I hope not. It means it's going down through the floor. That was my cat being annoying. Too many cats means too many problems. This will not be edited. Anyway, is this thing accelerating vertically? Probably not. It's not going down through the ground. It's not an elevator going up. So the acceleration on the y-axis is 0. Yay. So let's look at the free body diagram. Don't think. Let the free body diagram tell you what to do. I tend to go like clockwise around. So I'm going to start at the top. You ready for this? We have the normal force pointing up. I have 400 newtons at an angle of 25 degrees. I have gravity downward. That's going to be negative. And we know the mass, 225 kilograms times 9.8 meters per second squared. We have an applied force downward. And we don't know what it is, just applied force, but it's at an angle, so sine 30. And I think that's it. I should have, am I missing something? Nope, all 4 forces. They add up to a total of 0 because that's 0 newtons. That's not on, that's 0 newtons because it's not accelerating vertically. So now I look at this equation, this expression we've created using the FBD. I don't know the normal force. I don't know the applied force. Can't do anything. Oakley dokley. Step 4, ladies and gentlemen, kinematics. So I'm going to list my variables. I have initial velocity. I have final velocity, acceleration, distance, and time. Notice I'm just listing the variables. By now you should be experts at this. Now go back. Let's see what we can get from this. If I remember correctly, it is starting from rest. It reaches a velocity of 1.5 after moving 3 meters. So I'm going to fill all that in. 0 meters per second to start, reaches a speed of 1.5 meters per second after moving a distance of 3 meters. Alrighty. Now, if you're good, now we have everything laid out, all 4 parts, the free body diagram, forces X, forces Y, and kinematics. If you look at this, you should be able to say, oh, I can get the acceleration, which is the horizontal acceleration using kinematics, which I can bring here. I can use that acceleration to find the applied force. Once I get an applied force, I can put it here, and then, oh my God, I can get the normal force. Look at that. I didn't even think about how to solve. I just did it. Also, this question does not ask anything specific, like what is the normal force? What is the applied force? Of course, it would say that normally. My point in doing it this way is to show you that if you just set it up, all your unknowns will be solved for. So let's do that. Here I would use, I would go with MathRep 4 to find the acceleration. So you have 1.5, well, VF squared equals VI squared plus twice the acceleration times the distance. Excuse me, that was my cat being annoying again. 1.5 meters per second squared. This is 0 equals twice the acceleration times the distance. Solving for the acceleration, which will be the horizontal acceleration, we get 0.375 meters per second squared. I can then take that and throw it way up here. Sorry, that it's not all fitting on one page. After this, it's going to kill me to rewrite this. We have 400 newtons cosine 25 degrees minus 20 newtons minus the applied force cosine 30 equals 225 kilograms times the acceleration of 0.375 meters per second squared. Clearly, the only thing you don't know in this expression is the applied force, and we get 298 newtons. Yay! We can then take that applied force and throw it here, and then the only thing you don't know in this expression is the normal force. And just to save time, because you don't want to listen to me rewrite this entire thing, you would get that the normal force is equal to roughly 2,185 newtons. And that's it. That's your basic problem. They will definitely get more challenging, but the point of this video is to give you the general setup and problem-solving strategy with a solid example not something that's too easy or too difficult. Let's do a little review here. When it comes to dynamics problems, there are technically 4 parts to your setup. You always have the FBD, most important thing. Then you do the sum of the forces in the X, sum of the forces in the Y, and your kinematics. Do you always do those other 3 things? Maybe not. Maybe there's no kinematics because maybe it's not accelerating. Maybe it's going at a constant speed, so the acceleration will be 0, as written in red here. But we use the FBD to create the expressions, and when you set up each part, I mean, like if you do it that way, you should be able to create a plan and solve. It should be all in front of you and be like, yep, I can get this. I'm going to put that over there. I can get this. I can put that over there and get that. Let the problem-solving strategy do the work for you. Let the physics happen. Don't overthink it and try to figure out what to do. Most people are like, I don't even know where to start. Did you draw a free body diagram? Do I have to do that? If that's still you, we need to talk. Draw the free body diagram, use it to set up expressions for the X and the Y. If you do that, it works out. The people that overthink it and try and get the answer in their head without writing anything on paper, those are the people that struggle. Don't be that person. Please trust me. I've been doing this, I don't know, like a few days. I just started. I don't know. But I think I know what I'm talking about. Speaking of which, this video was amazing. Giving it 3 out of 5 stars, and I wouldn't change a thing.